Welcome to another episode of Learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We have been discussing the solutions of the problems that have appeared in the JEE Main exam held in the January 2025 session. And today's lecture is the third part of the three parts of Binomial Theorem. That means this is the last part for the Binomial Theorem. Right. This question has appeared in the JEE Main exam held on 24th January 2025 in the morning shift. For some n not equal to 10, let the coefficients of 5th, 6th and 7th terms in the binomial expansion of 1 plus x to the power of n plus 4 be in an arithmetic progression. Then the largest coefficient in the expansion of 1 plus x to the power of n plus 4 is. Right. Let's now discuss the solution of the problem in detail. Before that, we are given 4 options. The options are option 1, 35, option 2, 20, option 3, 10, option 4, 70. We are given n not equal to 10. The coefficients of the 5th, 6th and the 7th terms in the binomial expansion of 1 plus x to the power of n plus 4 are, it is n plus 4 C4. 5th means 4 plus 1. Term r plus 1, r is 4. Right. 6th term. The coefficient of the 6th term n plus 4 C5. 7th term. The coefficient is n plus 4 C6 respectively. We are given these three are in arithmetic progression. Then given they are in arithmetic progression, 2 times the middle term n plus 4 C5 is equal to sum of the extremes, that is n plus 4 C4 plus n plus 4 C6. Right. Write the formula for NCR. NCR is n factorial by r factorial into n minus r factorial in the denominator. That is 2 into n plus 4 factorial by 5 factorial into n plus 4 minus 5 factorial is equal to, similarly, the remaining 2 are written. Right. Now simplify. That is 2 times n plus 4 factorial we have cancelled throughout in the numerator, and in the denominator 5 factorial into n plus 4 minus 5, that is n minus 1 factorial in the first ratio. The second one 5 factorial 4 factorial into n plus 4 minus 4 n factorial plus 1 by 6 factorial into n minus 2 factorial. Now look at the denominators. The LCM is 6 factorial into n factorial. Now multiply throughout by the LCM. 2 times 6 factorial n factorial by 5 factorial into n minus 1 factorial is equal to 6 factorial n factorial by 4 factorial into n factorial plus 6 factorial into n factorial by 6 factorial into n minus 2 factorial. Right. 6 factorial by 5 factorial is 6. N factorial by n minus 1 factorial is n. So 2 times 6n. 6 factorial by 4 factorial is 6 into 5. Right. and n factorial by n factorial is 1, 6 into 5, plus 6 factorial by 6 factorial is 1, n factorial by n minus 2 factorial is n into n minus 1. Agreed. Multiply. Now simplify. You get n square minus 13n plus 30. Factorize. The factors are n minus 3 into n minus 10 is equal to 0. This will give rise to the values of n. N is equal to 3, 10. We take n is equal to 3 because it is given n not equal to 10. Right. We take n is equal to 3. Then the expansion 1 plus x to the power of n plus 4 will become 1 plus x to the power of 3 plus 4, that is 7. 1 plus x to the power of 7. 1 plus x to the power of 7 means when expanded the binomial expansion, it will have 8 terms. And what are the middle terms? What are the largest coefficients? The largest coefficients are the middle terms. It will have 2 middle terms. So now the largest coefficients we said in the expansion of 1 plus x to the power of n plus 4, that's equal to 1 plus x to the power of 7, are the coefficients of the middle terms. The middle terms are 7c3 and 7c4. So out of the 8, the first 3, last 3, the middle 7c3, 7c4. And they are equal. 7c3 is equal to 7c4 is equal to 35. So the largest coefficient in the expansion is 35. Where is it? It appears against option 1. Therefore, the answer to this question is option 1. That is the detailed discussion of the solution of this problem, and it is a very simple and straightforward question. We move to the next question. Right, this question has appeared in the JEE Main exam held on 23rd January 2025 in the second shift. The given question is, if in the expansion of 1 plus x to the power of p into 1 minus x to the power of q, the coefficients of x and x square are 1 and minus 2 respectively, then p square plus q square is equal to, we are given 4 options. Option 1, 18, option 2, 8, option 3, 20, option 4, 13. Let's now discuss the solution of the problem in detail. We have 1 plus x to the power of p into 1 minus x to the power of q. Straight away, we write the expansion for 1 plus x to the power of p, that is 1 plus pc1 into x plus pc2 into x square plus pc3 into x cube plus so on and so forth into the binomial expansion of 1 minus x to the power of q is 1 minus qc1x plus qc2x square minus qc3x cube plus so on and so forth, because there is a minus sign here. Now multiply and write down. When you multiply, you will get 1 plus the coefficient of x we will write. The coefficient of x is 1 times pc1 into x, pc1, 1 times qc1x, that is pc1 minus qc1x, plus the coefficient of x square. The coefficient of x square is 1 into pc2, right, minus xc1x plus pc1x, that is pc1 into qc1 x square, that is written here, and qc2 x square, right? So this is what we have written. Those are the coefficients of x square plus the coefficients of x cube plus so on and so forth. We have not left any term up to this, right? So now in the product, what is the coefficient of x? pc1 minus qc1, and that is given to be 1, right? And the coefficient of x square is pc2 minus pc1 into qc1 plus qc2, that is given to be minus 2. So given the coefficients of x and x square are 1 and minus 2 respectively, this implies the coefficient of x is pc1 minus qc1 is equal to 1, that is p minus q is equal to 1. The coefficient of x square we are given minus 2, that is PC2 minus PC1 into QC1 plus QC2 is equal to minus 2. Right, PC2, P into P minus 1 by 2. PC1 is P, QC1 is Q, minus PQ, plus Q into Q minus 1 by 2 is equal to minus 2. Now take the LCM and simplify. You will get P square minus P minus 2PQ, you are taken LCM, plus Q square minus Q is equal to minus 4. Right. Now this is precisely P square plus Q square minus 2PQ is P minus Q whole square minus P minus Q, that is minus of P plus Q is equal to minus 4. So we have P minus Q is 1, substitute here and you will get the value of P plus Q. P plus Q is equal to P minus Q whole square plus 4. P minus Q whole square is 1 square is 1, 1 plus 4 is 5. So P plus Q is 5. What is that we want? We want P square plus Q square. How do we get? We know P plus Q, we know P minus Q. So we have 2 times of P square plus Q square is equal to P plus Q whole square plus P minus Q whole square. So that's the one. So P plus Q whole square is 5 square plus P minus Q whole square is 1 square. That is 25 plus 1, that is 26. This is 2 times P square plus Q square. We want P square plus Q square, so you will get 26 by 2, that is 13. So the answer to this, P square plus Q square is 13, it appears against option 4. Therefore, the answer to this question is option 4. This is also again a very simple and straightforward question. We move to the next question, and that is the last question in this video. This question has appeared in the JEE Main exam held on 22nd January 2025 in the second shift. The given question is, let alpha, beta, gamma and delta be the coefficients of x to the power of 7, x to the power of 5, x cube and x respectively in the expansion of x plus under the square root of x cube minus 1 whole to the power of 5 plus x minus under the square root of x cube minus 1 whole to the power of 5 where x greater than 1. If u and v satisfy the equations alpha u plus beta v is 18 and gamma u plus delta v is 20, then u plus v equal. We are given 4 options. Option 1 5, option 2 3, option 3 4, option 4 8. Let's now discuss the solution of the problem in detail. So we take x plus under the square root of x cube minus 1 to the power of 5, straight away expand by means of the binomial. So x to the power of 5 plus 5c1, 5, x to the power of 4 into square root of x cube minus 1 plus 5c2, that is 10, into x cube into under the square root of x cube minus 1 whole square, that is x cube minus 1, plus 10x square into under the square root of x cube minus 1 whole cube plus 5x into x cube minus 1 whole square plus under the square root of x cube minus 1 whole to the power of 5. In a similar fashion, expand by means of binomial x minus under the square root of x cube minus 1 whole to the power of 5. This is the same expansion as above, except alternately positive and negative will come because there is a minus here. So we got this one. Add. If you add, what you see is the square root of x cube minus 1 terms, square root of x cube minus 1 whole cube terms, square root of x cube minus 1 whole to the power of 5 terms, they cancel off. Then you will get 2 times x to the power of 5 plus 10x cube into x cube minus 1 in brackets plus 5x into x cube minus 1 whole square. Right. Now expand, multiply them, and write in ascending order. So this will be 2 times in brackets 5x to the power of 7 plus 10x to the power of 6 plus x to the power of 5 minus 10x to the power of 4 minus 10x cubed plus 5x. Right, simplification we have done rightly, right. Now, it's given alpha is the coefficient of x to the power of 7. What is the coefficient of x to the power of 7 here? 2 5s are 10. Beta is the coefficient of x to the power of 5. What is the coefficient of x to the power of 5? 2 into 1, 2. Gamma, the coefficient of x cubed. What is the coefficient? 2 into x cubed minus 10. 2 into minus 10 minus 20. Delta is the coefficient of x. 2 into 5, 10. So, we are given two simultaneous equations in u and v. And alpha u plus beta v is 18. And gamma u plus delta v is 20. Substitute the values of alpha, beta, gamma, delta. Then you get these equations. In these equations, the first equation 2 is common, cancel off. In the second equation 10 is common, cancel throughout. Then you will get 5u plus v is 9. Minus 2u plus v is 2. Now solve for u and v. We know how to solve them. Yeah, I am sure you will solve it. And after solving we get u is equal to 1, v is equal to 4. What is that we want? U plus v. U plus v is equal to, u is 1, v is 4. 1 plus 4, 5. Where is the answer? The answer appears against option 1. Therefore, the answer to this question is option 1. That is the detailed discussion of the solution of these problems. Right. We conclude in this video from the section Binomial Theorem. There are 11 problems that have appeared in the January 2025 JEE Main examinations. And all these 11 problems we have worked out. 4 in the first one, 1 by 3. In 2 by 3, another 4. In 3 by 3, the rest, that is 3 more problems we have worked out. I am sure that you have understood the solutions of all these problems. Thank you for watching my video. Now, please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am sure we are going to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.